And she used to work with Kennedy Space Center for 20 years, and now she's in an organization called CASIS. And CASIS is the Center for Advancement of Science in Space. Doesn't that sound really cool? Is space a cool place to do science? Yes, of course it is. So, yeah, so she's, and she actually, this isn't her first time to the museum. She was here for Astronomy Days. Has anybody here been to Astronomy Days? Well, you guys all need to come. It's in January every year, and it is an awesome event all about astronomy and space. So Debbie's going to tell us a little bit about some of the life science experiments that they do on the International Space Station. So thank you.
Thank you, Carrie.
I am so sorry. And I just also wanted to recognize Dr. Chris Brown, who is here from the University of North Carolina, and thank him for coming here to the program today.
Now, he's a real space experiment researcher back there. He actually, Dr. Brown had several experiments fly on the space shuttle, so you got to go talk to him too while he's still here. Well, welcome everybody. I'm going to, Rex gave you a lot of information about, what it's like to be an astronaut and flying in space. Well, unfortunately, I can't tell you that, but I am going to tell you about all the other things that we get to do when we go to space. So I work for the Center for the Advancement of Science in Space, or CASIS, and we manage what's known as the International Space Station National Lab. So this lab belongs to you, the people of the United States, and we manage it, and we bring companies and universities and researchers to come and do their experiments on the International Space Station. And I'm really happy to be here in North Carolina. Let's see what space is all about. So our crews go up on a Soyuz rocket from the Space Center in Russia. They hitch a ride up there, and then they dock to the International Space Station. And once they get on board, we have all kinds of facilities like freezers, like he was taking things out of the freezer in that photo. So while we're up there, we study microgravity. That's what happens when you don't have gravity. You can float around, and it impacts anything that goes up into space. So we can study plants and flames and even the effects on the humans and robots and fish. So the crew has to spend a lot of time exercising to stay healthy. They have ways to lift weights and run on the treadmill and even to do experiments on themselves. And a big component of what we do is education. We actually have a ton of student experiments, so kids just like you flying experiments. And then we can look back on the Earth, too. We can look back and see what we're doing to the planet. Maybe there's a disaster in some area of the world, or even just look at our crops and how they're growing. And, of course, we get to enjoy how beautiful it is, too. And then they cram themselves back into that Soyuz capsule and come on home. The International Space Station is truly international. We have folks from all over the world that are flying with us, Japan and Europe and Russia. So we share those duties on the International Space Station to do the experiments. We spent a lot of time building the International Space Station, but now we're there to use it to do experiments and to do science and bring that learning back here to Earth to help each one of you improve your lives. So the space station, a lot of people don't realize, how big it is. It's actually as long as a football field. So it's pretty big. And the volume where the astronauts can live is about the size of a 5-bedroom house. So I don't know, that's bigger than my house. I don't know about you, but that's way bigger than my house. And it's about 250 miles up in the sky. So that's about as far, somebody said, from here to Charleston. Does that sound about right? It sounds like a long drive. How many people have made that drive? Yeah, it's a long way. All right, so we got the space station up there now. We've spent a lot of time building it, and we filled it up. I don't know if you noticed or thought about it, but there's no ceiling or floor in the space station. So we can actually put experiments and hardware on all 4 of the walls, if you will, on the International Space Station. So we got lots of things that we can use. And we have lots of ways to get our experiments up to the space station. Of course, we have to carry those clean clothes. Remember, Rex said they didn't wash clothes. And we got to carry food, but a lot of what we bring back and forth are the experiments. So we fly on SpaceX. Anybody see the video from last night where they landed? They launched and then landed. I don't know if you noticed, but that rocket last night was going twice as fast as the one they landed in April. So they're really helping us to commercialize low Earth orbit and be able to get back and forth inexpensively. So we have the orbital ATK vehicle as well, and we have some international partners that help us out. And we have new vehicles in development to help us bring more experiments up to the space station. And one of the new ones there is called Sierra Nevada, and it has something that looks actually like the space shuttle, looks a little bit like that. And the nice thing about that is it'll land on a runway and come and bring more of our experiments home. And then we have what we call the Commercial Crew Program. Rex talked a little bit about it to you, but we're real excited about it. One of the reasons is because when that starts flying, we'll have a whole nother astronaut that's completely dedicated to doing experiments. Right now, we only have about 40 hours a week to do experiments with the crew members we have there, because they're busy doing what? They're doing maintenance, so they're changing the light bulbs, and they're fixing the toilet and cleaning their bedroom. So now when we have this extra person go up, they'll be completely dedicated to experiments, and we'll have twice as much time as we do right now. So this tells you a little bit about some of the equipment that we have. We have things that you might see in the laboratory here in this building. We have freezers, and we have glove boxes and centrifuges and pipetters and things that help us do our experiments. So mostly what we're bringing back and forth are the organisms that we're studying. We also have places outside the space station where we can put experiments. Typically, they have to go through the airlock because you have to reduce the pressure before you bring them outside. So we can't do that very often because we don't want to, use too many cycles on the airlock. So we're very careful about what we put out here. We want to make sure we get good results. So NASA's focused on research that's going to take them to Mars, take them to that next step of exploration. And so our job at CASIS is actually to use the space station to bring things back here on Earth that are going to help us. And so we're kind of there in that 4th level of what NASA's mission is, to help with the commercialization. So we've talked a little bit about, we've got all these experiments. Well, why? Why are we doing these experiments in space? Well, the biggest reason is we have these 4 forces. Some of you may be familiar with them and some of you may not, but one of the ones that we deal with every day is gravity. And when we take gravity, that thing that made the apple fall off the tree and knock Newton on his head, and think about that. When we take that out of the picture, we can study how these other forces affect our life. So, for instance, this gives you a little bit of a picture view of what that might look like. When you burn a candle here on the Earth, you get this beautiful flame, long and extended flame. But in microgravity, it doesn't look like that at all. It becomes this ball, this blue burning ball. And in fact, it can float away from the wick that it started it and just be this ball of burning gas until it uses up all the gas that we're burning with it. So it's really pretty neat to watch that and to study that, because then we can improve engines. So like diesel engines or gasoline engines, we can improve how they perform here on the ground. And if you look there on the bottom on the left, you're going to see water boiling. You'll notice here on Earth, when water boils, you're probably familiar with it in your kitchen, it makes little bubbles on the bottom, and then they float up to the top, and eventually they get bigger and bigger. But in microgravity, that doesn't happen. You get this ball of air, and it just gets bigger and bigger and bigger and bigger and just stays in that one spot because gravity's not there to create and change how that bubble acts. And the other thing that happens that's really interesting is sedimentation. So here on Earth, if you have, let's say you have some cough syrup that you've got, the doctor gave you to take, you'll see on the cough syrup it says shake well. Okay, and they want you to do that because the medicine that's in that cough syrup will settle to the bottom of the bottle. And if you don't shake it up and you just take some off the top, you're not going to get the medicine. Well, in space, that doesn't happen. Okay, so the medicine would stay all distributed in the fluid. So these are things that we can harness as experiments in microgravity. So here we have a giant ball of water. And one of the interesting things that we noticed, the astronauts noticed pretty much right away, is that water behaves very differently in microgravity. It'll form a ball and tend to stick to itself as much as possible, but then as soon as it hits a surface, it'll spread out on that surface as far as it possibly can. You'll notice it's climbing up his hand, and it's slowly going to climb all the way up his arm. And the astronauts say that's almost like slime. How many people here have played with this slime? Yeah. So we can also take experiments outside. We talked a little bit about that. And one of the interesting things outside the space station is when you put something out there, the temperature is going to go from 300 degrees Fahrenheit, so really, really, really hot, to minus 300 degrees Fahrenheit. So when the sun's out, it's going to be 300 degrees Fahrenheit. When the sun goes to the other side and we can't see it anymore, it's going to be really dark and really, really cold. So we can expose materials, and we even flew tomato seeds out there. And I actually have a packet of these tomato seeds. They flew in the early 80s. They were out in microgravity in space, in vacuum of space for about 5 years. And I figure I'm going to hold on till those till, maybe I'm 80 or 90, and then I'm going to grow them and see if they still work. So we can also look back at Earth. We can learn things about the Earth. We can learn about changes in rivers and how they're flowing. And when we have a volcano erupt or an earthquake, we can use those views to help us here on Earth. So this is another way that we can use that vantage point of being up there on the space station to help here on Earth. So a big part of what NASA does in the space station is take care of the astronauts. Okay, microgravity and being in space creates a lot of changes in their bodies. You may have heard about bone loss. The astronauts at one time when they would come back from space would have very weak bones, almost like osteoporosis. So over the years that we've been flying astronauts, we've developed methods to counteract that so that now when the astronauts come back, they actually have the same bone mass that they left with. But one of the things that you'll see here in this picture is Peggy Whitson. She's a wonderful researcher turned astronaut, and she's flown a couple of times and actually getting ready to go again. But there's a picture of her before and then while she's on the space station. Can you guys see that her face looks different? Her face is kind of puffy and rounder than normal. So one of the quickest things that happens when they launch, so when Rex leaves that launch pad and he gets to orbit, one of the first things that happens is the fluid that gravity would normally pull down into your legs ends up being distributed all through your body. So Peggy's face is all puffy and big because the fluid in her body is redistributed and she has more up top than she would normally. So we can do experiments. We can do experiments on crew members. They let us do some things. But for the most part, we spend a lot of time doing experiments on other organisms that we use as model organisms for human health. And this is an example. I picked a bunch of organisms that we flew that were primarily student experiments. So you'll see here we had big toad frogs that flew back on Space Lab J, STS-45, so that was a long time ago on the space shuttle. And then these other 3 experiments were all on the space station. So we had bees and spiders and even butterflies. The butterflies actually emerged from their cocoons and had to spread their wings out and see if they could still fly. So it was pretty neat. And Miss Spider down here, she had a little bit of a hard time readapting when she came back to gravity. If you go online to YouTube, you can see the video of these animals, either in space or when they come back. But Mr. Spider, there, Mrs. Spider, she kind of flipped over on her back when she was going after a fruit fly. She had a little bit of hard time flipping back over and walking again, but she readapted. It just took a couple of days. So we can also study cells, so cells of different tissues out of your body. So one of the things we can study is cancer. Cancer is a tough disease, and when we take those cells to microgravity, they behave more like they do when they're in your body. And so we can look at tumors and how they grow, and then look at ways to counteract that growth, and hopefully come up with drugs or other treatments that'll help folks with cancer. We develop crystals. So how many of you guys might have done those sugar crystal growing experiments, where you grow the sugar on the string? Have you guys done that? So we do something similar to that in microgravity, because we want to get really big crystals of molecules that we might use for things like drugs. And when we do those big crystals, then we can shine some light and do some imaging and pictures with them that tell us what the structure is. And so it's interesting, we have a drug right now that's in clinical trials for Duchenne's muscular dystrophy, and we flew that on the International Space Station and discovered a unique thing about the structure that actually helped improve that drug when they brought that learning back here to Earth. So this is what I'm talking about being able to harness that space station and bring that learning back here on the ground. So plants, I know this area is huge for agriculture, and plants in space is a big part of what we do. If you guys have been out to the exhibit, you've seen that freeze-dried food that the crew has to eat. I don't know about you, but I don't want to eat that for very long. It doesn't make my stomach feel good. So we're working on how to grow the food. So when we go to Mars or we go longer to explore, we can grow things. So we have the veggie unit on board now, and we have other facilities too. But this past year, we got to grow lettuce, and the crew actually got to eat it and have their first lettuce in space. So what we're learning there, though, we can bring back here, and things like water management and delivery of nutrients to the crops. What we're learning up there will help us do those same things here on the ground. So maybe we'll be able to grow lettuce that tastes better. I don't know, but we'll see. So we're also working, we've already translated some work that was done on water on the International Space Station. I don't know if you realize it, but everything on the space station is recycled. So when I say everything, I kind of mean everything. So the sweat that the astronauts give off goes into the air, and we collect that, and it's recycled and cleaned. When they use the bathroom, use number 1, they collect that and recycle it. So the astronauts like to say that, yesterday's coffee is today's coffee. So I know that sounds kind of weird, but one of the things that came out of that is that hardware that we built to work on the space station is actually being used now in remote locations to bring water purification to those locations. So we are trying to translate what we're doing, not just to go explore, but to also help life here on Earth. And one of our recent additions is a 3D printer. How many of you guys have 3D printed? I know a lot of people have that in their schools now, and we have one on board that has produced some tools for the astronaut. In this case, it was a socket wrench for him. And the interesting thing was the very first thing that we had the printer print was a spare part for the printer. How cool is that, right? All right. So a lot of kids here today, and you're probably sitting there going, okay, how do I be an astronaut? I want to do this stuff. Well, you don't have to wait till then. Okay, there are a tremendous number of projects where you can fly your own ideas to the space station right now. Okay, we have robots on space. We have people doing DNA work in space. Students just like you doing their work. We have the Tomato Spheres program where you can get seeds that were flown in space and bring them back to your classroom and do those experiments right here on Earth. So I challenge you to go home and Google spaceflight experiments for students and see what you see. There's several competitions out there that are open right now for students to propose experiments. So I don't know about y'all, but I hope I conveyed a little bit about why I do what I do. I love this job. I enjoy working in the space program. We're learning a lot and trying to improve life here on Earth, as well as help NASA move forward and go to Mars in the next few years. So any questions?
Okay.
I think we got a few,
All right,
a few
I've got
minutes
a microphone.
anyway.
I can walk around with it.
What about headaches? Do you get headaches when you go up there? I mean, have they tried stuff for migraines and people that suffer?
Yeah, so you can imagine by that fluid shift, there's a lot of aches and pains that go on in space. I don't know if Rex told you when he was up here, but he grew, I think he said, about 2 inches when he was in space. So you can imagine that stretching your spine like that is going to cause some aches and pains back there. And so they have a full medical kit on board, and one of the astronauts is always trained as a medical officer and can help, decide, what you need and how much you need. Because actually the drugs don't work the same in space on you as they do here on Earth. So where you might take 2 Tylenol here on Earth, you might have to take either less or more depending on which drug it is.
Just shout it out.
Okay, so if you are in space and you're conducting an experiment and one of the crewmates annoys you, like, a lot, what would you do about it? Once you're done with the experiment.
Well, I think those kind of problems are the same here on Earth as they are there. I haven't been there, so I can't tell you exactly what if the astronauts do anything differently, but you definitely, it's something that you've got to talk to the other crew member about, because you are going to be stuck together for at least 6 months up there on the space station. So I think they work those things out, and I think they have, they have a commander on every flight, and that commander helps resolve things like that.
Okay, thank you.
You're welcome.
What is it like to build a robot in space, or to shake hands with Robonaut?
Yeah, so that's pretty cool. We had some of him in the video. Did you see that in the video with the Robonaut? So Robonaut has, has everybody seen Robonaut, the pictures of him? He's sort of like the top half of a robot, and soon I think he's going to get legs. So NASA's been developing him and hoping that he can do some of the tasks instead of the astronauts. So wouldn't it be cool if we could have the robot fixing the toilet so that astronaut could come and do more experiments? So that's what we want the Robonaut to be able to do one day. But it takes a lot of time to learn how he's going to work and whether he's going to work in space. And they even might be able to remote control him from the ground to do things as well. But you have to remember that, if I send a signal from here on the ground and it's got to go 250 miles, it's going to take a little while, right? So we've got to work out all those things about talking to the robot too. So I heard part of that about more blood flowing to your brain, but I didn't hear the rest.
To make you smarter.
Well, I don't know. Most of the astronauts I know are already pretty smart. But you definitely, so the body adapts, so that in that beginning, that early couple of days when they first get to space, there is going to be more fluid, more blood, if you will, up in the top half of their body. But eventually the body adjusts and it goes kind of back to normal. So if they do get smarter because of that, it doesn't last very long. Let's see, where did Carrie go? Oh, go ahead.
Can kids like me go into space like right now?
So right now, children aren't allowed on the International Space Station, and that's really because being an astronaut takes a lot of training, and that would keep you from the schoolwork that you need to be doing. So you got to do that schoolwork first. But it's interesting that you ask that because, you know, when you ride a roller coaster and the roller coaster goes up and then it comes down really fast, at the very top of that roller coaster, you're actually feeling microgravity. So the next time you go on a roller coaster and you get to the top and you start falling down and you kind of lift out of your seat, that's actually microgravity.
Okay, how about up there on the 3rd floor?
You know, we have a whole program called Story Time in Space where the astronauts read books from space. So you can go, again, look that up on the internet, get your mom and dad to help you, and look up Story Time in Space, and you can see all the books that they have that they've read.
Okay, red shirt here?
I was wondering, have you ever tried baking powder and vinegar in space?
Well, I haven't, but let's think about what would baking powder and vinegar do. So here on the Earth, it like foams up, right, and pops out of whatever it's in. So the first thing we'd have to think about when we do that in space is we'd have to contain it, okay? So we'd have to put it in something that was closed and sealed. And if we did that, when we mix those two together, what's going to happen? It's probably going to go kaboom, right? Because the gas that you make is going to kind of make that explode. So it's probably not something we want to do, at least not outside the glove box in space. But it's a good idea for an experiment, so we could see what would happen.
Do you prefer bringing bottled water from space, or do you prefer to drink recycled water?
So the crew members that I've talked to say it doesn't taste funny at all. So I don't think we could launch all those bottles of water. It would take away from, you know, getting clean clothes and food and experiments up there. So it's most likely that we're going to have to recycle our water, especially if we plan to go to Mars. We're not going to be able to take enough water bottles with us. So I think we're just going to have to get used to it.
When you come down from space, so I've heard that when you're in space, your muscles get weaker. When you come back down to Earth, does it feel weird to walk on the ground with normal gravity?
Yeah, it sure does. You know, I haven't been in space, but I've worked with astronauts a lot on landing day, on the day that they land, within a couple hours afterward. And depending on how long they've been up there and how much exercise they've been doing, they can really have trouble standing up and you know, standing upright against gravity. Most of our crew members today, though, exercise about 2 hours a day. So they exercise a lot, so that, you know, if they come back, they're able to get up and walk around. They do get tired more quickly even when they get back, because there is, you know, it's like they, you know, been running a marathon or been laying in bed for a long time. They're really tired when they get back, so they have to kind of take it easy.
What if you stuck your foot out in space?
Oh, well, I don't think you want to do that, okay? So in space, when you get outside the spacecraft, there's no air. So you can't breathe, and, you know, it's not a good place to be. It's really cold, or it's really, really hot. So that's why the crew members wear those suits. Have you seen those suits? Did you see the one out at the exhibit? So that's why they wear those suits. Those suits have temperature control inside to keep them nice and cozy and keeps them alive and everything functioning properly. So we can't go out into space without that spacesuit on.
Okay, up on the 3rd floor.
So if I tried to do what with water? Well, like I said, water behaves kind of weird. So, whenever you pour water or you do anything with water, the first thing it's going to do is make bubbles or balls, excuse me. And it's interesting. There's another video. Chris Hadfield was a Canadian astronaut. And he did a lot of videos with water, and he made a sphere of water. And then he had a syringe where he was shooting the water at the ball of water. And the interesting thing about it was that the water that he was shooting at the ball, it was much smaller, and it would actually bounce off the larger ball of water. It was very interesting. I mean, I would have intuitively thought that the little balls would have joined with the bigger ball of water, but that's not what happened. They actually are thrown away. And so that surface tension that's formed on that big ball of water is very, very strong. And things like that we can't study here on Earth because of gravity. So we learn a lot about those other forces that I showed you up there when we take gravity away. And that's just an example of the things that can happen when you do that. So when they sleep, Rex flew, the astronaut that was here, he flew on the space shuttle for the most part, and they had these sleeping bags that they could kind of string around wherever they wanted to. And on the space station, each of the crew members has what's called a sleep station. I always think it's about the same size as a telephone booth, but nobody knows what that is anymore. So it's a pretty small room, about as wide as a doorway. If you think of a doorway square, a square made out of a door, it's about that big. So they have, their computer in there, and they can watch movies and read books, and they have their own little light. So it's a nice place for them to get away and be quiet. And they have the same kind of sleeping bags too that they can zip themselves up into and just sleep there, kind of suspended in microgravity.
I have a question about that water bubble. If you were to put something in it that would break the surface tension, like soap, how would it behave?
Yeah, so anything when you mix like that, if you're going to change the charge, right, that's on the outside of the water, is going to change how it would behave. So that's a great example of an experiment that folks would have done. So there's another video where they made a water bottle, and they had the candy corn. And he took the candy corn and put oil on one half of the candy corn so that it would be attracted to the water, but the back half wasn't. So he made this like floating ball of candy corn that was in the water. It was really cool looking. So again, if you go to YouTube with your parents and you do water in space, you're going to get a ton of great examples of what happens in microgravity.
What are some popular products or technologies that have come from research in space that we might know about?
One example that always comes to my mind is we did a series of 3 animal experiments in space that had to do with bone loss with a pharmaceutical company called Amgen. And the work that came out of that, they actually have 2 drugs on the market now for osteoporosis that came from that research with those model organisms. I mentioned that one with the Duchenne's muscular dystrophy. It's in clinical trials, but there's also a golf club that's actually out on the market right now, a Cobra Puma golf club, the Super LTD King Cobra. And they did some materials research with us on the International Space Station, and they just released that club, I think it was last November. And the engineering that went into that club all came from that research on the International Space Station. So it can be fun things as well as things that really, really help us here on Earth. But there's lots of things coming. We've got almost 70, I think, experiments flying this year alone. And I think about 70% of that is all commercial companies doing research.
Okay, let's do 2 more questions. So 3rd floor and then 2nd floor. Say that again? Say that again?
So would it be safe to drink water from space on Earth? Was that the question? Yeah, so, yeah, no problem. In fact, you know, when the space shuttle used to fly, you know, before there was a space station, we made a lot of extra water, and they would bring that back down here on ground. So it's the same molecule. It doesn't change. There's nothing wrong with it. You could definitely drink it when it came home. Yeah, so the facilities to do that kind of work are very complicated because you have to have the right kind of habitat, you know, just like you see here in the museum. So those facilities are really too big for us to accommodate on the International Space Station. So we've just, you know, kind of limited what we do experiments on, primarily because we can do things with smaller organisms. That, you know, we can learn similar things and not have to do that with the larger organisms.
Okay, Debbie, thank you so much.
welcome,
And everybody,
Carrie.
please make sure you head out and see the destination station parked outside the globe. Thank you.
Thank you, Carrie. Thank you.